Okay, you guys, we're on page 5. So let's remind ourselves of those. What was the identity that I wanted to get at everybody tattooed with?
Sine squared plus cosine squared equals 1.
Perfect. Sine squared, what kind of variable do we want to use? X, theta, A, B, what do you want to go with? So, like, just keep it simple. Sine squared plus cosine squared is 1. I say it like Lobley did. I don't say the X, I probably should, but I write the X. So if you don't want to say it, I'm fine with it. Make sure that we write it. Then you guys, how do we get that second one? What could I divide everything by to get this one? Sure. He said, okay, if I were to divide through by cosine squared, if I divided through by cosine squared, and you don't have to write that step if you don't want, what would turn into a sine squared over cosine squared? A tangent squared. Thank you. What would cosine squared over cosine squared turn into? A 1. And what about a 1 over cosine squared? Perfect. 1 over cosine is secant. Goody gumdrop. And then the last one, Hen, you had us divide through by cosine squared. What could I divide through by to get the other one? Sine squared, the other start. If I divided through by sine squared, sine squared, sine squared. Okay, you guys, sine squared over sine squared? 1. Cosine over sine. Cotangent, since they're both squared, I'm going to square that cotangent squared. And then 1 over sine, cosecant. We do not need to have those memorized. We just need that process memorized of how we can come up with those other two. In my 9 years, I still haven't memorized them. Maybe I will at some point, but I doubt it. You know how this brain of mine works. I'm not going to remember those. You guys, I'm going to skip this for now. It's no bigs. I don't need us to lose sleep over it. Here's why I like 7-2 more than 7-1, and I think you're going to like it too. Yesterday, I gave you something like this guy, and I said, hey, go simplify it. And now I'm telling you, go simplify it, and it better equal that. So the nice thing about 7-2 is you know what it's got to simplify to. So does this equal that? I've made it a statement, so absolutely it does. We just need to show them how we could do that. Are there many different ways? Yeah. Do I suggest always starting at the bigger side and condensing it down to the smaller side? Yes. Could you blow this side up to equal the left side? Yes. I just think it's a lot harder to expand something to match as opposed to decompose something to match. Okay, peeps. Any ideas what we could do over here? If we were to start with this bigger side, any strategies like that we could use from yesterday? I love it. Remember yesterday we wrote on our page, write things in terms of sine and cosine. How could I rewrite? Oh, you're saying you don't even want to rewrite that one. Interesting. You're onto something. What's a tangent minus a cotangent? I'm sorry. Tangent times a cotangent. Yeah. Could we think of that as sine over cosine times cosine over sine? You're saying, man, a tangent and a cotangent, they're just reciprocals of each other. Because I'm multiplying between them, I can just cancel things out. And I've got -1. And interesting that you didn't want to change that secant squared. But you're very smart because you're onto something. What is secant squared -1? As soon as we see things squared and with ones, we want to refer to this stuff. Secant squared -1. Do you guys agree I can move that 1 over? Boom, I'm left with tangent squared. Is that what we want over here? Oh, snap. So you're saying secant squared x -1 is just tangent squared. And did I get what I started with? Sure did. Did I only mess with one side? Sure did. We're done. You guys, anyone have a preference? Again, there's no right or wrong answer. If Ava says, I feel like working on the left, and Kira says, I feel like working on the right, great. We can get there either way. One way might be easier than another, but we might not know it till we get on our adventure. Anyone have a preference or something be like, oh, I guess my gut would have told me to start on the blank. Anyone having a gut feeling on this one? And when you don't have a gut feeling, you just got to pick one. You want to start on the right? I'm fine with that. So what could we do on the right? 7 times Perfect. Plus 5 times. Okay. And maybe, Lob, you're like, I didn't even need to write it that way. Maybe you wanted to condense it right off the bat. 7 times 1 cosine could just be 7 cosines, right? And Lob, we got to get this. How many fractions does this involve? One big one, right? And right now I got 2. How do we combine fractions? Common denominators. You know I'm too lazy to say that, so I'm going to say let's get some commons. Let's get some commons. What would these common denominators need to be? What does this guy need? Sine and a sine. Mm-hmm. What does this guy need? Cosine and a cosine. Appreciate you. Oh! I like what I see. What do we have now? She says, my denominator's already matched, so I can go ahead and add those numerators. Miss Ava, is that what we needed? You're like, oh, we're there. Where do we want to start on this beauty? It's like, heads or tails, right? Left or right? I heard a vote for left. We down with a vote for left? I'm down with it. Let's try it. Sine over, how could I rewrite cosecant? 1 over sine. Do these signs cancel? They don't? Why not? One's in the denami, one's in the numi. I agree with that. So that's just good to know. What about the cosine divided by the secant would be cosine divided by 1 over cosine. I love it. I can't mess with the right side. Let's think about sine divided by 1/9 is the same as sine times what? Dividing by this fraction is the same as multiplying by its reciprocal. What's the reciprocal of 1/9? Sine. Love it. And cosine divided by 1 cosine is the same as cosine times. Beautiful. What does that simplify to be? Oh, then we got our matching tattoos. Sine squared plus cosine squared. What do we know that is? Do we remember sine squared plus cosine squared is 1? Now we're like, dude, how am I supposed to turn 1 into this mess? Has 1 and it's got some squareds in it. 1 and some squareds in it. You guys, 1 and some squareds in it. We need a 1 to turn into cosecant squared minus cotangent squared. Is cosecant squared minus cotangent squared an identity? If I just said, hey, cotangent squared, go get a new seat. Can I move it over there? It equals 1. So this does equal cosecant squared A minus cotangent squared. And therefore, I got what I started with. Again, we might not be feeling groovy on those yet, but that comes from that Pythagorean identity. What if we kind of notice that right off the bat? We're like, right off the bat, you're like, I was kind of looking at the right side, and I know that right side is 1. You might even want to write yourself a little note, like you know that one's 1. So even though I can't work on both sides, if I knew I got this left side to 1, then I'm like there. You know what I mean? So I know we can't work on both sides, but if you knew, you're like, oh, cosecant squared minus cotangent squared, that's 1. So if I got there on the left, I know that I'm there on the right. Just something to think about. On 9, which side just lends it a little easier? You're like, okay, I feel like I know I could do something on one side. The left side. What kind of spoke to you, Lob?
That is square. So
Agreed. You're like, cool. My gut would be to go square it. I love that, Lob. Let's do it. So we got sine of A minus cosine of A. He says squaring it just means we got 2 of them. And don't you dare be saying that equals sine squared plus cosine squared, because it don't. Okay, here we go. Let's distribute it, you guys. What do we get when we got sine times sine? Beautiful. And then what about sine times negative cosine? Beautiful. Negative sine cosine, she said. And here? Same thing. And we might want to write it negative cosine sine, but since Lexi already said negative sine cosine, I'm definitely going to keep that. Bless you. I'm going to keep that order. And then it would end with
Cosine squared.
beautiful, plus cosine squared, right? Hey, what's sine squared plus cosine squared? We love that. We got a 1. Lob, does that make you feel warm and fuzzy? Because I see a 1 right there. Warm and fuzzy. I know. I can tell. I can tell. How many sine A cosine A's do I have if I've got -1 minus 1? -2 sine A's cosine A's. I just saw Lexi got warm and fuzzy too because she sees a -2. She's like, oh my gosh, this is great. Guys, this is great. Now here's where we're not going to get warm and fuzzy. You're like, how am I going to turn this into that, right? Okay. Question. If I multiply the number 9 times 4/4, what do I still have? Do I still have 9? Is that 9? Because that's really 9 times 1, which is 9. Or you could even think that that's 36/9, which is just, Nope. That's not what I meant to do. Yeah, 9 times 1 gets me 9, right? Sorry, I wrote that wrong. That'd be 36/4, which is 9, right? If I multiplied that straight across. Okay, so what if I did 5 plus 9 times 4/4? What if I did that? Yeah, she's saying, well, 9 times 4/4 is still just 9 times 1. 5 plus 9 is 14. Is that the same as 9 plus 36/4, which is 5 plus 9, which is still 14? Why do I do this? Because, you guys, what could I multiply sine by to turn it into a sine squared? I could do that. I could say, I want to say sine times sine gets me sine squared. But I didn't say just times 4 over here. I can't multiply my 9 just by a 4. That's going to change the problem. What could I put that sign over just to make sure it's a 1? Could I say times sine sines? Is sine sines just 1? And I want you to be uncomfortable at this step. You're like, what? I would have never thought of this. I don't expect you to. That's why we had to talk about it today. Do you guys agree sine times sine gets me a sine squared? So I'm allowed to do that because I just multiplied part of it by 1. I didn't multiply just this part by sine. I multiplied the part by 1, and 1 isn't going to change anything. What would I be left with then here? Yeah, cosine over sine is just cotangent. So you're going to be like, I would have never come up with that. I hear you. But we were kind of warm and fuzzy, and we just had to make this match. I'm allowed to multiply any portion of an equation by 1 anytime. I didn't have to multiply this guy by sine over sine because it's just 1. I could have, but I didn't have to. It's not going to change anything. So that is funky, and I understand that that is funky. But we are left with 1 minus 2. So we just kind of manipulated the problem. Sine squared of A times a cotangent of A. And I got that by multiplying this by a sine sine. If I just needed to match that sine squared, if I multiplied this by a sine, I would need to multiply this by a sine. But because I kept it a sine sine, it's just a 1. Oh yeah, I like this one. I like this one. This one's a quick one. Ideas. Left side, right side. Sure. What do you want to do on that left side, Henry? 1 over, beautiful, minus. What do you notice about those denominators? They're the same. Can I add anything up then? Yeah, if my denominators already match, how do I combine them? I just get to add those tops, right? 1 minus sine over cosine. Are we done? Oh my gosh, we love those, don't we? Okay, last one, and I'm going to have you guys practice something. Last one. Ideas on this guy. Do you want to start on the left or the right? The rate, all I know to do on the right is write that as 1 over cosine. Then I'd have to blow it up, and I don't know how I'd do that. You know what I mean? Now you're not wrong that once we do the left, you could see if we undo the left, you're doing the right. You know what I mean? So we can see our strategy because I like that you're open for the challenge. I do. Any ideas? What the what? What the what?
We rewrite tangent, we can get rid of cosine.
Oh my gosh. Okay. I love what you started with. You said, let's rewrite tangent. Terms of sine and cosine every time, right? So we got sine over cosine. Here's my problem, lob. You want to know what I hate? These things. Because of the adding, we cannot cancel things out. If things were just being multiplied, I love it. But the adding is a nuisance. But here's what I want you to focus on, lob. Do you agree we got a lot going on and we needed to turn it into one thing? Could we start with just focusing on the NUME? Meaning, can we just combine at least those two different things to be one fraction instead of two things? What could I do with this 1 to be able to combine with that sine cosine? 1 times what over what? Yeah. Cosine over cosine is just 1. I'm not changing the problem, but it's getting me a commdom. Up top, what would I have? Good. Just make sure that you're saying cosine plus sine, right? Over cosine. You guys, I'm going to have you save yourself some ink of your pencil. Some lead of your pencil. You guys agree this? Oh, I did not highlight that. This is that, yeah? Dividing by this guy is the same as multiplying by its what? Reciprocal. I like to put these things over 1 to help me see that reciprocal. What is the reciprocal of sine plus cosine over 1? 1 over sine plus cosine. Hey, Lob, remember how you wanted to cancel some things out earlier? Now that I'm multiplying, Lob, what do you notice up here? Sine plus cosine is the same as that one. And because I'm multiplying between them, you get to say, whoopsh, whoopsh. That's when we get to do that. Because we had the same quantity and we had multiplication between them. Sound good, Lob? What's left, you guys? How'd you get there? 1 over cosine is beautiful. And that's what we needed. Question that I need to ask you. What if Henry, in his smart aleckness, just wrote this side, and then his one step was just equal secant? Is he wrong? He's not wrong is what they gave us, right? So you can't do that because they already told you it's equal to each other, right? We need to just make sure that we can show the steps to show that they're equal. I already told you that they're equal. I gave you the answer. We got to just be able to show the steps to get there. And some people like to skip their steps here. Not as much as Blake Harville, though. Okay? So